Hello, madam. Please, concerning the course material you sent to the group now. Please, ever since you sent the course material, I've not been able to open it because if I try to open it, it has been popping up some error. Yeah.
Hello, can you hear me now?
Yes, please, we can hear you.
Okay, sorry about that. I was having some issues with the internet over here. Let me share the screen again. Okay, well, I'm getting ready to share. I think we just listen to me. So, what is going
Hello,
on here?
hello.
Okay, so I was saying that
Hello, madam.
in the previous class, yeah, can you hear me? Is the sound bad too?
Yes, please.
Can you hear
Madam,
me?
please. No, everything is okay.
Can you
Yes,
hear
please,
me?
madam. I can hear you. Yes,
Okay,
please.
okay, all right.
Madam, please. There's something wrong with the course material you said in the group. Yeah. Anytime I try to open it, there's an error open up. I'm not able to access the course material you sent.
Is it breaking the line?
No, the line is not breaking. It's clear. But then I'm having trouble with the course material you sent to the group
Okay,
the other
okay.
day. So,
It's a
maybe
zip
after the class.
folder. It's zip.
Pardon?
So you download and you unzip it. You download it and then you unzip it. It's a zip folder.
Oh, okay. Okay. All right.
So you
But
have
then,
to.
please, after the class, can you resend it to the group so that I can do that?
Oh, okay, sorry about that. So as I was saying, the material is a zip folder, so you just download it and then you you unzip it. If you still don't have access, you can send me hi on WhatsApp and then I'll send you the files individually one by one. So either you try unzipping it or you just send me a hi on WhatsApp and then I'll send you the materials one by one so that you have access to it there. Okay, so I was saying that in the previous class, in last week's class, we looked at we started with matrices where we looked at the introduction, focusing mainly on the various what matrices are and the types of matrices. So we basically started here looking at what matrices are. Then from there we looked at the types of matrices that we can have. So we went through all of this. Then from there we also went on to start with the various operations that can be performed on matrices. So we started with the addition, then after we were done with the addition, we looked at the subtraction. Then after subtraction, then we went to look at the multiplication. So with the multiplication, we looked at the scalar multiplication, and then we also looked at the matrix multiplication, otherwise known as the dot product multiplication. So that's basically what we did then. From there, we also looked at the inverse and then the transpose, trying to determine if a matrix is symmetric or not. Then we saw these questions and then we said we can try our hands on these questions. And then we also have the assignment question that was also shared with us. So that's basically what we've done so far. So for the assignment, I've received 1, 2, 3, 5 5 submissions have been received so far. So if you are yet to submit your assignment, you can just send it. I think the deadline for submission should have been yesterday. So either you type it out or you write it and then you take pictures and you send. However you want to do it, just get it done and then you send it to the email that has been indicated. So I've received 5 so far. So yeah, yes, to submit it, you can just do it and then send it to the email. So that's basically with what we've been able to do so far. So in today's class, we are going to be looking at the determinants of the matrix. So how do we calculate the determinants of matrices? That's what we'll be looking at in today's class. So that's what we are going to be focusing on. Then when we are done, then continue with the subsequent things and then we'll call it a day when it comes to matrices. So that's basically what we'll be doing. Okay, so we are going to be starting with determinants now. So I'm gonna use it. Okay. So I was saying that we'll be starting with determinants now. So the determinant basically refers to the it basically refers to the value so the determinant refers to the value of so when we ask you to calculate or compute the determinant of a matrix, at the end of the day, what you do get is a value, a scalar value. So it will be either 1, 20, 125, 0, negative this, or so it's either a positive number, a 0, or a negative number. So that's basically how so that's basically what happens when we calculate the determinants of the that's basically what happens when we calculate the determinant of a matrix. You can see that the determinant is a scalar value, and then you compute it from the elements of a square matrix. So the square matrix has come again. So remember when we were looking at the transposing and the symmetry, we were focusing on square matrix. And then when we were also trying to look at the multiplication and all of that, we saw the importance of the square matrix. So the square matrix has come back again. So to be able to compute the determinant of the matrix, to be able to compute the determinant of the matrix itself have to be a square matrix. That's
Yeah. Pastor, how many what side people I can't planting from?
planting. What's your paper, babe? Alfred. Alfred. Oh, office na it was staircase. Actually, when I was yes.
Good afternoon. Is it giving you
Hello. Sorry about that. I had to resolve the issue with the internet over here. Okay, so I was saying that for the determinants, we get the determinants by computing the value. So the elements inside the square matrix. So let's say we give you a 2 by 2 matrix A and another 2 by 2 matrix B, and then we say calculate or compute the determinant of the matrix A and then the matrix. So what you basically do is that you take matrix A, you look at the elements inside or the items that you can find inside that matrix, and then basing it on that, you are able to compute the determinants from there. Or it can be a 3 by 3 matrix or a 4 by 4 matrix, but we'll be focusing mainly on the 2 by 2 and then the 3 by 3 matrix. So that's basically what you are going to be looking at. So to be able to compute the determinants, the determinants would depend first one that the matrix is square, so it's 2 by 2, 3 by 3, 4 by 4, as I've been saying, and then the value for the determinant is going to be a scalar value, just as I said earlier. So it's either be a positive numbers, negative numbers, or it's going to be 0. It can be a fraction too, but then it's not going to be an equation. At the end of the day, when you are done computing the determinants, you end up getting a single value. So for a square matrix A, if we say compute the determinant is going to be denoted as follows. So you see over here. So if you have the question can either go, it will give you the list of matrices. So you see matrix A, matrix B, matrix C, in that order. Then it will say compute the determinants of the following matrix. Either it goes like that, or it can give you the matrix, then it will go calculate determinant A, determinant B, or it will just give you as has been done over here. So either you get it like this way, the sentence method, where we give you the list of metrics, then we give you what you are supposed to do, as in you are supposed to calculate the determinant, or you find it using the notation method, either using this or using that. So at the end of the day, when you are done with your calculation and then you find the value of the determinants, you just use this to represent it. So if it was a matrix B, you have written determinant of brackets B is equal to, then you put the particular value there, or you could have just used the second method where you go like this. So determinant of B is equal to, just like that. So you can do it using any of the Then the next that we are going to look at is the properties of determinants. So the determinant of an identity matrix, you remember what the identity matrix is. We said the identity matrix is a matrix that has 1 on the main diagonal. So this place is 1, this place is 1, everywhere else is a 0. So you can either look like this for the 2 by 2 matrix, or for the 3 by 3 matrix, it will look like this: 0, 1, 0, 0, 0, 1. So like this. So the identity matrix, that's this example and then this example. If you find the determinant of it, the determinant is going to be 1. Then the next is that the determinant is the product of the diagonal elements. So that's basically the formula that we use. So for the 2 by 2 matrix, if we were going to be finding the determinant, it would be the product of this and then the product of this, something like this. So the determinant is the product of the diagonal element. Then the next says swapping 2 rows does not change. Swapping 2 rows changes the sign of the determinant. So assuming we had a matrix B, so B is equal to 2, 1, 4, 3. So this is original B, and then we swapped its 2 rows. So that's the first row became the second row, and then the second row now becomes the first row. So we have a new B, which is equal to 4, 3, and then 2, 1. So this is the original B that we had, and then this is the B when we swap the 2 rows. So whether we are computing for this or computing for that, we end up getting the same value. So if the determinant was 2, so if the determinant was 2 for the first B, that's the one in purple, the purple color, this B. So if the determinant for this was 2, then the determinant for the B that we swapped the 2 rows is going to be -2. So that's the difference when it comes to the determinant. So first, for the identity matrix, you are always going to get a determinant of 1. Then the determinant is basically the product of the diagonal elements that you can find in the matrix. Then if you have a matrix B that is a 2 by 2 matrix, it has only 2 rows. So the matrix B has 2 rows. You compute the determinant, you get a particular value. And then you swap the 2 rows. So the first becomes the second and the second becomes the first. When you compute the determinant for that particular new matrix that you have, is going to be the same value. The only thing is that the sign will be different. So if the first original matrix was positive, the next one, when you swap, will be negative. If the original was a negative value, when you swap it, you end up getting a positive value. Then the next one says that multiplying a row by a scalar multiplies the determinant by that scalar. So we are still going to be using the B. So if we multiplied B by a scalar value, so we multiplied B by 2, so 2B. So the scalar multiplication, I'm sure you remember how that is done. So with that, you just multiply each element in the matrix by the particular value. So if we are multiplying B by the value of 2, or the scalar value of 2, we end up getting 4, 2, 8, 6. So you compute the determinant, and then you see that the determinant is basically the original matrix. So this is the original B that we have. So this original B, the value that you had for the determinant is just going to be, so this is going to be determinant of, let me change this method rather, this determinant of B, this one is the opposite determinant of B. So this is just going to be 2, the determinant of B. So it's just the determinant of B that has been multiplied by 2. So that's the other rule that we have to take note of. Then the next says that adding a multiple of one row to another does not change the determinant. So if you have an original matrix, we are still using B just so we can easily follow the original matrix B, and then you multiply one of its rows with the other one. So it basically means that looking at this original B that we have, it will multiply the first row by the second row. If you do that and you compute the determinants will still not change. Then the last one basically says that if you have two matrices, so we have matrix A and then matrix B. So over here we have two matrices, matrix A, matrix B. And then we say compute the determinants of these two matrices, or compute determinants of AB. So you could have first gone through the multiplication method where you multiply matrix A by matrix B. Then when you are done, the results, you find the determinant of that. So that's basically what this one is about. So with this one, it means that we took matrix A and matrix B, we multiplied them, and then when we were done, we computed the determinants of the matrix. So if you do this, the value that you get is the same as if you had just computed the determinant of A and then multiplied it with the determinant of B. So that's basically what this is about. So this says you have two matrices, A and B. If you are going to be finding the determinants of the multiple, the result of the multiplication of the two matrices. So you can either go through the A times B, you multiply them. When you are done, the results, you find the determinants. If you follow that process, there is answer that you get. It will be the same as someone who found the determinants of A, then the person also found the determinant of B, and then multiply the determinant of A by the determinant of B. So these are basically the properties of the determinant. So the first that we've seen basically is that the identity matrix, no matter how you go about it, if you find the determinant, you end up getting one, no matter what. Then the next is that the determinant, we compute it based on the product of the diagonal. So that's the next one. Then the third is if you swap two rows, so you have a matrix, you swap the rows, so the first becomes the second becomes the first. If you find the determinants of the swapped version and the determinants of the original version, it will be the same value, just that the sign will change. So if it was, the original was +5, then the swapped version will become -5. Then the fourth is basically multiplying a row by a scalar multiplies the determinant by that scalar. So if you have a matrix B, in this case we use matrix B. So matrix B, we found the determinant of that matrix B. And then we said, okay, using this matrix, we are going to multiply it by a scalar value of, say, 2. So find the determinant of 2b. If you find the determinant of 2b, you realize that it's basically the determinant of b that you've just multiplied by 2. So it means that in this case, too, if you were to be given a question that says find the determinant, and then we gave you a matrix, and then the question was a scalar multiple, you could just find the determinant of the original matrix, and then when you are done, you just multiply it by the scalar that has been given. Either you go through that process, or you do the scalar multiplication, and then you find the... All right, Bernard, noted. So either you do the scalar multiplication, and then you find the distance, the determinant of that. So I'm recording the lesson. When you are done, by tomorrow, you should be able to get the link. So the link for the video, I'll download it from the drive, and then I'll upload it on the Google listing, so you can also follow through from there. Okay. So as I was saying, so if you have a matrix and then you do the scalar multiple of it, it will still be the same as the determinant of that matrix that you've multiplied by a scalar value. And then the last one says that if you add one row, the multiple of one row to another, it doesn't change the determinant. And then the final one says if you have two matrices, A and B, if you multiply the two and then you find the determinant, the answer that you get is the same as if you found the determinant of the first, you found the determinant of the second matrix, and then you multiply the two of them. So you still get the same answer. So how do we compute the determinant? So remember, in the properties of determinants, we said that the determinant is gotten from the product of the diagonal. So you can see from here, let me use so if we have this 2 by 2 matrix, so we had the 2 by 2 matrix A. So if we have this matrix A, and then we said we want to find the determinant of the matrix, what you'd basically do is that you get the product of the diagonal. So this is the first diagonal, or the main diagonal. So you get AB. Then you take the product of the second diagonal. So this particular diagonal, as you can see, BC. So this is how you compute the determinant of the matrix. So you have matrix A, it's a 2 by 2 matrix. So it satisfies the condition that you can only compute the determinant for a square matrix. So it's 2 by 2, so we can compute the determinant. So how do we compute the determinant? We are going to be finding the product of the diagonals, and then we subtract it from each other. So the main diagonal comes first. So the blue comes first. So we multiply A and B together over here, minus the result of the other diagonal, and then C, as we can see over here. So we are going to be looking at some examples. So we have 3 matrices that would be looking at. So we have, all of them are 2 by 2 matrices. So we have A, B, and then C. And we've been asked to find the determinants of the two matrices, sorry. So we are going to be using the formula, and then we'll find the determinant. So we said the determinant is gotten from the product of the diagonal. So this is the first one. So we look at the main diagonal. So we have 4 and then 1. So we come down, and then you see that you are multiplying 4 and then 1. Minus, then we go to the next diagonal. So the next diagonal is over here. The values is 3 and then 2. So 3 and 2 or 2 and 3. Then 4 by 1 would give you 4, and then 2 and 3 would give you 6. And then when you do 4 minus 6, you see that the value is minus 2. So then the determinant of A is going to be minus 2. So this is basically how you do the determinant. So you can see this is pretty straightforward. It's not complicated. All you need to do is first you take your main diagonal. So the main diagonal, you get the elements there or the items there. All you do is you multiply the two of them together. So 3 and 4 will give you 12. Then you go to the next one, you take the next diagonal. So the element in the next diagonal is 2 and 1. So we are multiplying 2 and 1 together. The value will give us 2. So 12 minus 2, then we see that the determinant for E is going to be 10. So this is how we compute the determinants. The same has been done for C and then B. So for C, you see that we have 2 and 3 because for the main diagonals, the value here is 2 and the value here is 3. So 2 times 3 is 6 minus the other diagonal. So the other diagonal, we had 5 and then 1. 5 times 1 is 5. So 6 minus 5 gives you 1. So you can see that the determinant for C is 1. Then we have the final example. So that was D. So D2, we've been asked to find the determinant. So you see in the first one, we're using the first notation for determinants where you write determinant. So DT bracket, and then you put the matrix name there. So that was what we're using. So or you can represent it using the second notation where you use the horizontal lines and then the matrix number or the matrix name or identifier is found inside there. So from here, the main diagonals, we have 3 and 6. So 3, 6, we get 18 minus. So in this case, you have to look at the signs very well. So you see in the matrix itself, you have 1 and then minus 4. So 1 and minus 4 will give you minus 4. But then the sign that we are dealing with is minus. So it becomes 18 minus minus 4, which gives you 18 plus 4. And then the result that we have is 22. So this is how you compute or how you calculate the determinants for a 2 by 2 matrix. Are we all okay so far? Is it okay for us?
Yes, madam.
Okay. So we're moving to the next one. So I said for the determinants, we are going to be looking at the 2 by 2 matrix, and then we'll also look at the 3 by 3 matrix. So that's basically what we'll be looking at. That's what we are concerned with when it comes to the determinant. So we've done the 2 by 2 matrix. That's very straightforward. I'm sure we can all see it's very straightforward. Then the next that we'll be looking at is the 3 by 3. And the 3 by 3 matrix one is also straightforward. You just have to pay particular attention to what you are doing, and everything would be okay. So with the 2 by 2 matrix, it was just 2 rows. So we just take the main diagonals, the multiplication of the product, and then we subtract the other diagonals product from the results that we had for the main diagonals. So for the 3 by 3 matrix, it also follows through the same thinking or the same mindset. So what I would basically be doing is, the first thing would be to find the determinant for each particular item. Find the determinant for each particular item on the first row. So I'll use a different color so that we don't get so color black. So this row. So this is row 1. So you can see we are finding in the formula that we are using, we are finding the determinants for each particular row that we are looking at. And then when we are doing that, what you basically do is, if you take the first item, so in this case, we are concerned with item A. So when we take the element A, we are going to be finding the determinants of that element. So when you strike through, yes. So when you take this element, you strike through like this, and then like this. So you see that we are only left with this particular element, that's EF and then HI. So then you compute the determinant as we have been doing previously. So it will be E times I, which you find over here, minus H times F, which we find over here. When you are done with this, then you go to the next element. So this element is B. So you strike through this, and then you strike through this. Then you see what you have left is the D, F, and then the J, I. So you do the same thing. So D will multiply with I, and then F will multiply with J. So that's 2 will be done. Then we'll go to the next or the last element that we find in or on the first. So when you strike through with the row and then the column, what you have left is this particular one. So D and then H minus J and then E. And then we take note of the signs. So for A, when you find the determinant of the matrix or the 2 by 2 matrix that is left, when you cancel out the row and the column that A is found in, you basically do it like, so A is black. So that would be this. Then when you are going to be, the sign that we use is minus, just as with the other one. So the other one we go to positive and then we went to negative. So this would be for B. Then the last for C is plus. So it's A and determinant of the 2 by 2 matrix that results from it, minus B, the determinant of the 2 by 2 matrix, plus C, then the determinant of that 2 by 2 matrix. Basically like this. So this is how we compute the determinant of the 3 by 3 matrix. So as I said, it's the same as with the 2 by 2 matrix. Only thing with the 3 by 3 is you have to take your time so that you pay particular attention to which elements you are looking at and you don't get confused and write the wrong elements. So you pay attention. If you are dealing with A, you cancel out A's row, A's column. What is left over here is what you look at. If you are dealing with B, you cancel out B's row like this with a red mark. So with a red. So you cancel out the column and then you cancel out the row. So everything else that's there's going to be a 2 by 2 matrix. Then you find the determinants of the resultant 2 by 2 matrix. If you are dealing with C, you cancel out the column, so the yellow line. So you cancel out this column, you cancel out this yellow line row. What you have left is a 2. Oops. What you have left is a 2. What you have left is going to be a. What you have left is going to be a 2 by 2. A 2 by 2 matrix. Then the resultant 2 by 2 matrix, you find the product for that. So this is the formula that we use. This is the formula that we use when we are computing. Okay. That's the formula that we use when we are computing the determinants for the 3 by 3 matrix. So from here, we are going to be looking at some examples. So please let's just pay attention and then certainly understand what is being done. So we have 3 matrices here, A, B, C, and then they are all square matrices. So remembering again that we said for square, to determine, to compute or to find out the determinant of a 3 by of a matrix, it first has to be a square matrix. So we have this, and then we're going to be finding determinants. A, B, and C are all square matrix because they are all 3 by 3 matrix, which means that we can find their determinants. So how do we find their determinants? As I said, let me look at the colors I use so that it's still the same. Black, red, yellow. Okay. So if you are going to be finding the determinants, I said we are concerned with the elements on the first row. So we have this first row. So for each element, you find the determinant of the resultant 2 by 2 matrix that comes when we cancel out that particular element. So we are taking the first one, which is 1, right? So if we cancel out one's column like this, then we cancel out one's row like this. What we have left is this. So this 2 by 2 matrix was untouched. So 5, 6, 8, 9. So what you do is that you find the determinant of the 2 by 2 matrix. So how do we find the determinant of 2 by 2? You just multiply the main diagonal. So that's 5 times 9. So you can see 5 times 9 has been multiplied over here. And then we multiply the 8 and 6. So you can see that over here. So 5, 9, 45. 8, 6, 48. Then you compute the result that you get is going to be -3, as we can see over here. Then we go to the next element. So the next element on the first row is 2. So we take 2, we cancel out the column that 2 is found in. We cancel out the row that 2 is found in. What we have left, or the elements that are untouched, is the 4, 6, and then the 7, and then the 9. So this is a 2 by 2 matrix. How do we compute the determinants of 2 by 2? You just multiply the main diagonal. So 4 times 9, we can see that over here, and then 6 times 7, we can see that over here too. Then we compute 8. So 4, 9, 36. And then we come here, 2 minus 6 times -6 is -12. But then the operation being performed is subtraction. So then it becomes a positive. And then you get positive 12 over here. Then you go to the last element. So you do it for each of them. All you need to do is just pay attention to what you are doing. So you cancel the elements in the column, then you cancel the elements in the row. When you are done cancelling the elements in the column and then the elements in the row, what you would have left is going to be a 2 by 2 matrix. So this yellow line column, this yellow line row, the only thing that the yellow line didn't touch was this particular 2 by 2 matrix. So 4 times 8 is computed over here, and then 7 times 5 is computed over here too. Then you compute the entire thing. So 4, 8, 32, 5 times 7 is 35. You get minus 3. Remember that the operation is positive, sorry. So let me change. So this is positive, rather. So the operation that we are performing is a positive. So 3 times minus 3 is minus 9. Minus 9 plus is going to give you minus 9 still. So then you compute that, and then when you add, you see that the final result that you have was 0. So remember we said the determinant, if you compute, you get a scalar value. So it can either be a 0, as I said, a positive number, or it's going to be a negative number. So in this case, the determinant that we had, the result was 0. So that's the determinant of this 3 by 3 matrix. So this is basically the process that you follow. So you do it step by step, one by one, and then you pay particular attention to the operation, because that will change the values that you get. So the first, after the first element comes, the operation is minus. Then you do the second element, then the operation is plus. Then the third element would come there. So this is basically how you compute the determinant of the 3 by 3 matrix. So we are going to be flowing through the same thing to compute the determinant of the next matrix, or the next element, which is the other 3 by 3 matrix. So I said we compute it focusing on the elements in the first row. So first you take note of your first row elements. Then when you are done taking note of your first row elements, you take each item one by one. So this is the first item in the first row, the 3. So I cancel out the 3's column, the column that is found in. I cancel out the row that the 3 is found in. What is left is going to be a 2 by 2 matrix, and then I focus on that 2 by 2 matrix to compute the determinant. When I'm done, I'll go to the very next element, so the second element. So for this one, it's 4. So the column goes out, and then you also cancel its particular row. When you are done, what is left? So what the red is not touching is this 2 and 1, and this 7 and minus 2. So this is a 2 by 2 matrix 2. So you just compute the determinant of that, and then you multiply it by the element that we are looking at, which was 4. Then you go to the very last element. So in this case, the last element is minus 1. So you cancel minus 1, the column that is found in. Then you also cancel the row that the minus 1 is found in. What you have left, or what the yellow line is basically not touching, is this 2 by 2 matrix. So that's 2, 0, 1, minus 3. Then you just compute from there, and then you determine the matrix that you are going to be working on. So that's basically what we can find over here. So in the first case, we had when we cancel the first row, we had 0, minus 2, and then minus 3, and then 7. So if you come here, we can see that that's basically what we are doing. So we found the 0 and then minus 2 in the inside, and then 3 and then 7 and minus 3. So 0 minus 2 is 0. 7 times minus 3 is minus 21, but the operation is minus, so it will become a positive. So we've computed the determinant of the 2 by 2 matrix over here. Then we multiply that by the elements that we're looking at. So 3 times 21 is going to give us 63. Then you do the same thing for the second element, as I said. So the second element is 4. So for 4, when we cancelled out its column and its row, what we had left was this 2 by 2 matrix. 2, 7 for the first row, and then 1 minus 2 for the second row. So 2, 7, 1 minus 2. If you are going to be finding the determinant, it will be 2 times minus 2, and then 7 times 1. So if you come down here, you can see that's basically what we are doing. So it's what has been done over here. So 2 times minus 2 is done over here, and then 1 times 7, 2 is done over here. 2 times minus 2 is minus 4. 1 times 7 is 7. The operation is minus. If you come minus 4 minus 7, which gives you minus 11. Then you multiply it with the elements that we are concerned with, 4. So it becomes minus 44. But the operation is plus. So minus 44 would give us positive 44, as we have over here. Then you go to the next one, which is the last element. So the last element here. The last element is minus 1. So we think that we cancelled out its column, we cancelled out its row. What we are basically left with was this particular 2 by 2 matrix. So that's 2, 0 for the first row, 1 minus 3 for the second row. If we want to compute the determinant, it will be 2 times minus 3 and then 1 times 0. So if you come down here, you can see that is exactly what we are doing. So we have 2 times minus 3 minus 0 times 1. So 2 times minus 3 give you minus 6. 0 times 1 will give you 0. So it becomes minus 6 minus 0, which is still minus 6. So the operation here, remember I said we should pay attention. So the operation here is positive, but then positive, the number itself that we're looking at was minus 1. So this will become minus 1. So minus 1 times minus 6 is going to give you a positive 6 over here. So it will become 63. So the determinant of B as we have it is going to be 63 plus 44 plus 6. So when you are done computing at the end of the day, the particular values that you end up getting is going to be 113. So this is a positive number. So you can see that the determinant is also positive over here. So this is how you compute the determinant of the 3 by 3. So with the third matrix 2, you go through the same process. So with that, I'll just draw the lines through. So we are concerned again, as I said, with the elements in the first row. So we get our first row elements. That's the first step that we do. Immediately we are done with that, then we start looking at each particular item in the first row. So we cancel it. For the first element, you cancel the row is found in and the column. The subsequent 2 by 2 matrix is what we look at. Then you go to the second element in the first row, you cancel the column is found in, and then you cancel the row that is found in. The subsequent 2 by 2 matrix is what you are concerned with. Then you go to the last element, you cancel the column is found in, you cancel the row is found in. The subsequent 2 by 2 matrix is also what you look at. So you can see that is what we basically, that's basically what has been done over here. So we have the first element, you find the determinant of that. Then you do your computations. You can see it has been done over here. Then you follow through here. And then you follow through here. Then you also do the computations for the second element. So over here, then you break it down, of course. Then you continue breaking it down until you come to the final one. Then you go to the very last element that is found there. Then you continue to break it down like this. Then you break it down again, continue breaking it down, and then finally at the end, the determinant of C is 28 plus 16 minus 66. So this particular determinant, we ended up with a negative number. So you've seen determinant can be 0, determinant can be positive number, and then the determinant can also be a negative number. So this is basically how you compute the determinants of a 3 by 3 matrix. So we've seen the 2 by 2 one. So I'm going back to the top so that we can see the formula for the 2 by 2 matrix. So if you have a 2 by 2 matrix, as I said, the determinant is pretty straightforward. So you have this matrix A. The determinant is just going to be the product of this main diagonal minus the other diagonal. What you have left, or the results that you get, is the determinant. So this is pretty straightforward for the 2 by 2 matrix. When you come to the 3 by 3 matrix, the first thing you need to identify is the elements in the first row. Immediately you get your elements that you can find in your first row, then you compute the subsequent 2 by 2 matrix that comes or results when you cancel out the row elements and the column elements that the particular item in the first row is found in. So for A, we saw that when we cancel it out, we have E, F, H, I. So that's a 2 by 2 matrix. You find it. For B, when you cancel it out, you have B, F, G, I. So you compute the determinants for that 2 by 2 matrix, you multiply it by B. Then you go to the third matrix. When we canceled A out, the 2 by 2 matrix left was D, E. So let me put the 2 by 2 matrix here so that it's easy to understand. So the 2 by 2 matrix was like this: D, E, J, I. So that's basically what we are doing here. And then in this case, what we are looking at for the 2 by 2 matrix was D, F, and then J, I. So that's what we can find over there. Then for the first one, the 2 by 2 matrix is going to be E, F, and then H, I. So that's also the 2 by 2 matrix that we had left here. So that's basically it. So when you take that element, then you find the 2 by 2 matrix by elements, the 2 by 2 matrix, the determinants, the elements, the 2 by 2 matrix, the determinant, you compute it, and then finally, when you are done, the result that you get is the determinant of that particular 2 by 2 matrix. So, sorry, of that particular 3 by 3 matrix. So that's basically what we've done over there. So this part is some further questions that we have. So these are just questions for you to try your hands on. So these are questions that you can be trying your hands on. So we have some that are 2 by 2, some that are 3 by 3, and then some you can see for this example, the PS. You are going to be finding the results of this J. The J is going to give you some particular equation, you solve it, and then the value that you get to be the determinant. So this is basically what we have. So you can try your hands on them and then you try to see if you understand what is going on. Do we have any questions? Any questions, or is all good so we can continue from there?
Um, I have a question.
Have a question, okay.
Please,
Yes, I'm
concerning
listening.
this deterrent thing, I'm asking
Wait,
how many marks is allocated to this question?
concerning the
Detergents.
concerning the word. Hello, can you repeat your question, or you can type it out? Either you repeat it or you type it out. I didn't really get what you said. Does anyone else have a question? Any other question? So you can just repeat it, or if you can't, because I couldn't really hear you, you can just type it out. Do we have any other questions? Any other questions? Do we have any questions? Any questions? Any questions? Okay, so we'll be continuing from there. So that's with the determinant aspect. So that's how you compute the determinants of a matrix. So we only look at the one for the 2 by 2 matrix or for a 3 by 3 matrix. So that's what you are concerned with. And then the first thing you always check is that the matrix is a square matrix. So it has to be 2 by 2 or 3 by 3. If you get anything else like a 4 by 2, 2 by 3, anything that is not square, you know automatically that you can't compute the determinant. So for such a question, you just provide that the determinant cannot be computed, and then you explain why it can't be computed. For anything else that is a square matrix, you just go through the process and then you compute the determinant. So the 2 by 2 process is very straightforward. You just get the diagonals, the main diagonals, you get a product, then you look at the other diagonal, that is, you get a product, and then you just subtract this other one from the main diagonal. For the 3 by 3, it's the same thing. The only thing is that you take the elements in the first row, and then for each element, when you cancel out the row that is found in and the column that is found in, there's going to be a 2 by 2 matrix left. And that's 2 by 2 matrix. You find the determinant and then you multiply that by the elements that we were concerned with. So you just take your time and then you go through the process step by step. And then when you are done, you'll be able to get the determinant of the particular 3 by 3 matrix that you are looking at. So that's how you basically compute the determinant. So the next that we are going to be looking at is the inverse of the matrix. How do we calculate or how do we compute the inverse of a matrix? So the notation has come again. So with the notation of the determinant, we saw that it was determinant. So DET and then brackets, then the particular name comes, or you use the vertical lines, then you put the determinant name inside. For the inverse too, it follows, it has its yeah, so this is basically how we know the inverse of a matrix. So when we are looking at the inverse, you see that we have that matrix. So this is the denotation. What I've put the black box on. So we see we have matrix A. Then if you are computing the inverse, at the top we have a -1. So that basically shows that this matrix has been inverted, or this is the result of an inverse that was done on a particular matrix. So if you see this anywhere, it's on the exams paper, you know that, okay, so this was an inverse matrix, or we are supposed to find the inverse of that particular matrix. And then the first property that we find is that if a matrix is invertible, so you can say a matrix is invertible if and only if. So this is what we pay attention to. So if and only if the determinant is non-zero. So this one too is building on. So you can see everything that we've been doing has been building on to each other. So we first looked at our matrices, then we looked at the various types of matrices, then we looked at the various operations that can be performed on them. Then when we were done with that, we started looking at the symmetry transpose. So everything was building on. Then we want to look at determinants, and now we are going to look at inverse. And for inverse, we've realized that we can calculate the inverse if and only if the determinant is a non-zero. So for all matrices that their determinant is zero, we can compute the inverse. Like this one, we had an example up here where the determinant was zero here. This particular matrix, so matrix A, when we computed the determinant for matrix A, we had 0. So the 0 means that because the determinant is 0, we can't calculate the inverse. So if we had been asked to calculate the inverse of this matrix, that is A, the results that we would have gotten would have been a 0. So that's basically what we take note of. So you can only compute the inverse for matrix that their determinant is not 0. Then the next is that for a square matrix A, its inverse is such that, so we have square matrix A. So let's say we had A like this. So we will use the simplest one, the 2 by 2 matrix, so that it's easy for us. We had this. So this is the matrix A that we had, right? And then we're saying that if you have A, and then you find the A inverse, so we had A, and then we found A inverse, which is this. If you take this A, right, that we had, and then you multiply it by the A inverse, so that's the first way, which is this. So you have A, you multiply by A inverse, if you do it this way, or you decide to multiply the A inverse rather by the A, as we can get here, the result that you get is going to be an identity matrix. So if you have a matrix A, so this is something that can help you to see if your answer is correct. So let's say we had a question, we had matrix A, B, C, D, blah, blah, and we said calculate the inverse of the following matrix. Then you've calculated, but you want to check if your answer is correct. All you have to do is that you take that matrix that you were given, then the inverse results that you have gotten. When you do the multiplication, your results should be an identity matrix. So if it was a 2 by 2 matrix that you were given, like this A, and then you did the inverse and you had the A inverse, if you want to just check if your answer is correct, you can just multiply the A by the A inverse, and then you get the identity matrix. So the identity matrix would be like this. So your answer after your multiplication would be like this. So that's if it was a 2 by 2 matrix. If it was a 3 by 3 matrix and you did the inverse, if you want to confirm, you multiply your original matrix by the inverse matrix, then you get the identity matrix. That's the 3 by 3 identity matrix. So that particular one is going to be the one that looks like this. So you get something like this. So this is basically what you get. So this just helps you to see if the answer that you had was correct or not. So we are going to be looking at the how we find the determinant for 2 by 2. So, sorry, the inverse. So we start with the 2 by 2. Then when we are done, we'll go to the 3 by 3 measure. So the same thing. So we said that to find the inverse, first, the determinant must not be 0. So we can see over here. So this, if we have a matrix A, which is this, if the determinant is not 0, then the inverse is calculated this particular way. So this is the formula you use to calculate the inverse of the 2 by 2 matrix. So I'll be taking it, and then we get to see what each part is about. Please give me a moment. Okay, so as I was saying, we'll be looking at the inverse of the 2 by 2 matrix. So to be able to calculate the inverse, first it has to be one that the determinant is not 0. So if you have a 2 by 2 matrix A where the determinant is not 0, and then we wanted to compute the inverse, this formula is what we would be basically using. So the formula basically goes like this. So A inverse is equal to 1 over the determinant of A. So it means that first, before you even compute the inverse, first you have to calculate the determinant. So if you have a matrix A and then we ask you to compute the inverse, the very first thing is to compute the determinant. If the determinant is not 0, then you go to the next point, which is calculating the adjoint. If the determinant was 0, you would have concluded from there that because the determinant is 0, it means that we cannot compute the inverse from there. So that's basically what we do. So in this case, first we get determinant. So it's going to be 1 divided by the determinant. And then the next thing that we do is to compute the adjoint. So you see, let's just follow through what I'm doing right now. So we had the original matrix, which was A over here, and then we had our B, that's for the first row element. Then we had C, and then D for the second row element. So this was what we had, right? And then we want to compute the adjoint. To compute the adjoint, what you basically do is that this two, the main diagonal, so the main diagonal is the A and B part, we swap them. So this an arrow sign here, arrow sign, and then I'm putting a cycle just so you know that they so something like this. So you swap the two main diagonals, and then for the other diagonal, which are not the main diagonals, you negate them. So this is basically what we have. So that at the end of the day, when we are done, what you would get will be this. So A and B are going to be swapped. So then the B will come up, and then the A comes down this way. And then we negate the other diagonal. So this B has become minus B now. And then this C has become minus C. So this is basically how you find the adjoint. So this is what we call the adjoint. So the adjoint is represented this way. Adjoint of A, like this. So this is basically what the adjoint looks like, or how you find the particular adjoint. So the first thing that we do is to find the determinants. So we have to see the determinant is 0 or not, right? So after we were done with that, we saw that, okay, so the determinant is not 0, or the determinant was 0. If the determinant was not 0, it means that we can find the inverse. So what we will do next will be to find the adjoint. To be able to find the adjoint, what you basically do is that you find the reverse. So what you do is you take your main diagonals A and B, and then you swap it, and then for the other diagonals you find the negative of it. So that's going to be the adjoint. So you see that the A and B have been swapped. So it's now B and then A, and then the B, which was positive, has become negative B, and the C, which was also positive, has also become negative C. So this is basically how you compute the adjoint. So when you are done, you just put in the values there. So you get your 1 over the determinants, which is going to be multiplying through the adjoint. And you see that 1 over the determinant is going to be a scalar value. So what you end up with is you'll be doing the scalar multiplication on the adjoint that you have gotten. So that's basically the process that we follow. So we have a matrix A, this particular matrix. Then we see that it's a 2 by 2 matrix, of course. So it's a square matrix. It has the first row element as 4 and 3. And then the second row element is 2 and then minus 1. So step 1, as I said, is you compute the determinant. So what is the determinant of this? Is a non-zero. So that's the very first thing that we do. After we are done with that computation, then the next that we do is that we compute the adjoints. So for the matrix, what is the adjoint? So I said for adjoints, the main diagonal, you swap it. So what was first becomes second, what was second becomes first. And then for the other diagonals, you negate them. Then from there, what you get, you just compute the inverse. So it will be 1 over the determinant that you had. So that would be a scalar value times the adjoint matrix that you've computed. So it will be that scalar value times your adjoint. So what you'll be doing would be a scalar multiplication on your adjoints. The results that you have will be known as the inverse of your matrix. So what you get finally is the inverse of matrix A that you were asked to find. If you had wanted to confirm if your answer is correct, all you do is that you multiply that inverse that you have gotten with this actual matrix or the original matrix that you had, and then you use that to see if you get a scalar value. If you get a scalar value, then it means that your answer for the inverse was correct. So that is basically how we compute the inverse of a 2 by 2 matrix. So we'll look quickly at the solution and then go from there. Please, I hope we are okay so far. Everything is understandable for us. Is everything okay with us? Okay, so the matrix that we had was matrix A. So A was equal to, the first one, it was 4 and 3. So 4, 3, and then on the second row, it was 2 and then 1. So this is basically what we are looking at. So that's the matrix that we are concerned with. So you can ask to find the inverse of this particular 2 by 2 matrix. So step 1 was for us to find the determinant. So to be able to find the determinant, what you would do is you just follow the determinant process. So you just go through your multiplication. So you multiply this main diagonals over here, and then you end up with this and then this. And then you also multiply the other diagonal, and then you end up with 3 times 2. 3 times 2 gives you 6. 4 minus 6, you see that at the end result, your determinant of A is -2. So that means that the determinant is not 0. Since the determinant is not 0, it means that we can compute the inverse of that particular matrix. So that was step 1. So step 2 would be for you to compute the adjoint of the matrix. So we are now going to be computing the adjoint of matrix A. To be able to compute the adjoint of matrix A, I said we just take the particular matrix. So to find the adjoint, you first swap the diagonal elements. So this diagonal elements, you see that they have been swapped over here. So 4 has now come down, and then now 1 has gone. So 1 is now on top, and then the 4 has now come down, as you can see over here. So that was step 1. Then the next is that you change the signs of the other diagonals or the off diagonal. So the signs have been changed, as we can see here. So now it was +3, it has now become -3. And what was +2 has also now become -2. 2. So what we have finally is what we refer to as the adjoint of A. So if we are using the symbol or the denotation, we could just use the ADJ, which is adjoint, and then you put your matrix that you are concerned with there. So adjoint of A. So this is basically how you compute the adjoint. So the next will be to compute the inverse. So we had the determinant. The determinant was -2. So that's what we had. And then we have the adjoint to the formula for inverse is 1 divided by the determinant. So 1 over -2 times the adjoint that we had. So you just do a scalar multiplication. So -half times 1 will give you -half. -half times -3 will give you +1.5. -half times -2 will give you 1. -half times 4 will give you -2. So then we can say that the A inverse was this. If we wanted to find out if it was correct, all we would have done was to compute the A inverse like this times the original A. So what we have is this A inverse, which is -half, then 1.5, then 1 -2. Then we'll multiply it with the original matrix that we had. So the original matrix that we had was 4, 3, 2, 1. So the first row was 4, 3, 2, 1. So this is A originally, and this is A inverse. If you multiply the two of them, the result has to be the identity matrix. So you get this particular identity matrix. So this is how you compute the inverse. This is how we compute the inverse of a 2 by 2 matrix. So this is the first example that we look at. Then this is the second example. So this other example is given a matrix B, which is also a 2 by 2 matrix. So given these 2 by 2 matrices, we've been asked to find the inverse. We've been asked to find the inverse of the matrix. And as I said, to be able to find the inverse of the matrix, the first thing that you do is to first compute the determinant. So the first thing, step 1, is to compute determinants of the matrix. So determinant of A is going to be 3 times 4 minus 2 times 1. So at the end, the value that we had was 10. So we see that the determinant for matrix A is 10. So the determinant is non-zero. If the determinant is non-zero, it means that we can compute the inverse of that particular matrix. So you see the reason why the determinant mustn't be zero is that when we come here to the formulas, we can see here, we divide 1 by the determinant. So if the determinant was 0, it would have been 1 divided by 0. That would give us 0. We cannot compute this. So immediately you get determinant that is 0. You know that because of the determinant being 0, it means that the inverse is going to be automatically 0, because if you divide 1 by the determinant, and in this case the determinant is 0, the result is going to be 0. So we just take note of that. So that's the very first thing that we look at. Then we've computed this determinant. We had a 10, so this is not a 0, so we can proceed. The next thing would be to compute the adjoints. So we had the original matrix, which was 3, 4, 2, 1. So we swap the main diagonals. So we swap the 3 and 4. So the 4 now comes on top, and the 3 is now at the bottom. Then we negate the off diagonal. So 2 becomes -2, 1 becomes -1. Then you just do your substitution. So 1 divided by the determinant is 1 divided by 10, multiplying through the adjoints that we have gotten. So if we do the multiplication through, then we see that this is what we had. So we can simplify some further, and then you can either leave it in the fraction format like what has been done over here, or you leave it in the decimal way, that if you can compute the decimals from there. So you either get one that is in the fraction method like this, or you get one that is in the decimal way. So this is basically how you compute the inverse. First, you compute your determinants. When you are done with your determinants, then you compute the adjoints. When you are done with the adjoints, then using the substitution, you just compute your determinants from the results. You simplify it as much as possible. So if you can leave it in the fraction way, you try to leave it as simple as possible in the fraction method, or if getting decimals is possible, then you leave it in the decimal way. So this was the process for the this was the process for the 2 by 2 matrix. So if you want to find the inverse of a 3 by 3 matrix too, it's also the same formula. So we can see from here, the inverse of the 3 by 3 matrix is still the same formula. The formula hasn't changed. So first, you find the determinant. So first, we compute the determinant of the 3 by 3 matrix. So remember how we computed the determinants for the 3 by 3 matrix. You take the element on the first row, and then for each particular element, you calculate the determinants of the resulting 2 by 2 matrix when you cancel out the row and the column that that element is found in. When you get that resulting determinant of the resulting 2 by 2 matrix, you multiply it by the elements that we are concerned with. So you go through that process for each particular one, and then you compute the determinants from there. And then the next would be to compute the adjoint. So when you are done computing the adjoint, then you would also multiply through so 1 divided by what you had for your determinant times the particular adjoint that you have. So this is the step-by-step process that you follow in calculating the determinant for 2 by 2 matrix. So as I said, in calculating the determinant of the the 3 by 3 matrix. First, step 1, we are going to be calculating the inverse. To calculate the inverse of a 3 by 3 matrix, step 1 will be to calculate the determinant. So from here, we can see we are calculating the determinant. So we've taken the first element, so like this, and then that is what we have over here. Then we've gone through it for the particular second element that we are looking at. So that one was like this, and then we've also done it for the third element that we are looking at, which was basically this one. So when we are done, the results that we had is going to be known as the determinant of A. So the determinant of A was -1. -1 is not 0. So that means that the determinant is not equal to 0. It means that we can compute the inverse from the inverse from there. To be able to compute the inverse, so we found our determinant. The next step is to find the adjoints, and to be able to find the adjoints of the 3 by 3. To be able to find the adjoint of the 3 by 3 matrix, what you would be doing is to be using the cofactor method. So we'll go through that. The cofactor, we already know this method. It's nothing strange. It's basically what we have been doing, just that now we do it for each particular element. So for the determinants, we are just looking at the elements on the first row. For the cofactors, and then finding the various minors, you do it for each particular element. So if you take this particular element 2, if you cancel out, the row is found in, the column is found, and you're left with 3, 2, 0, 1. See, that's what has been written here. If you take the next element, which is this one, if you cancel this column, right, you cancel this particular row, what you have left is 1, 2, 1, 0. So that's what has come over here. Then you go to the next one. So you do it for each particular one. So this one, when you cancel the column that is found in and the row that is found in like this, you end up with 1, 3, 1, 0. That has been written here. Then you go to the second row. So we are going to our second row now. In the second row, we take the first element. So we cancel the column that is found in, and then the row that is found in. What we have left is 1, 1, 0, 0. So you note that down. Then you go to the very next element. So the very next element is this 3. So you cancel out the row, column that is found in, and then the row. What you have left is 2, 1, and then 0, 0, which is this. So this place is supposed to be 2. Okay. So this is supposed to be 2 rather. Then we take the third element, which is this. If you cancel out this particular row and then this particular column, you end up with 2, 1, 1, 0. Then you go to the third row. So you do it for each one, as I said. So the third row, you take the first element 1, then you cancel through this and cancel through that. What you have left is this, which is 1, 1, 3, 2. So that's what we find over here. Then when you are done, you move to the next element. So this one you do it for each time, each of them. You'll be doing it for each particular element. So if you take this 0, when you cancel out the column is found in the row that is found in, what you have is 2, 1, 1, 2. So that is what we have over here. So 2, 1, 1, 2. Then you take the very last element. So this very last element. So that's also 0. You cancel out the column is found in and the row that is found in. What you have is 2, 1, 1, 3. So that is basically what we have over here. So you do this for each particular element. So for all the elements that you have in the matrix, you find their minus. So when you are done finding their minus, then the next thing that you do is to compute the determinants for each minor. So we have this. So there was a correction over here. So 22 is 2, 1, 1, 0, 22. So this is supposed to be 2 rather. So 2 times 0, the answer still doesn't change anyways. That will still give us 0 anyway. So for each of the minors that we've computed, we find their determinants. So you take the determinants method. So 3 times 0 is 0, 0 times 2 is 0. So this one, the result is 0. So you do for the next one, 1 times 0 is 0, 1 times 2 is 2, 0 minus 2 minus 2. So for each of them, you do for each particular element, the minus that you've gotten for each particular element or position that we are concerned with. Then when you are done, you get the minor values for each of them. Then what you do next is to compute the cofactors. So to be able, this process that we are going through is the process to compute the adjoint. So to compute the inverse, we needed the determinant 1, and then we needed the adjoint. So you've been able to compute the determinant for the entire matrix A. So we put that down. To be able to compute the adjoint, the first step is what we have done. So we computed the minors. And then for each particular minor that we had, we are computing the determinants for each of the minors, right? When we are done computing the determinants for each of the minors, as we can see here, so these are the minors, the A13 minor, the A21 minor. So you do the minus for each particular slot or position in the matrix. That's in the 3 by 3 matrix. So we computed the minus and we had the values for the minus. Then the next thing that we do is to compute the cofactors. So to compute the cofactors is just the result of the minus that we use, except that there's a particular denotation that we have to follow, which is this particular method. So we have the A11 is positive, A12 become negative, A12 positive. So it's basically, for the first row, it is positive, negative, positive. That's basically what we go through. The second row is negative, then a positive, then a negative. Then the third row is positive, negative, positive. So the values of the minus, if we come up here, we see that for A11, this value is what we had. So these values are what I'm talking about. So these values is what you put inside the formula to compute the cofactors. So these values, this is what we are concerned with. So we input those values over here. So you see, those values have come here, and then you take notes. So this is positive, negative, positive, negative, positive, negative, positive, negative, positive. You take note of the signs. The signs are very important because if you miss any of the signs, the result that you get is going to be different. So we take note of our signs and then we just work on it. So 0, 0, give us 0. Minus 2, give us 2. Minus 3, still minus 3. Minus 0 is a 0. Minus 1 is minus 1. Minus 1, give us a positive 1. Minus 1 is still minus 1. Minus of positive 3 gives us negative 3. And then 5 is still 5. So this is the cofactors. So to be able to compute the adjoint, or you can call it the adjacent, what you basically do is that you find the transpose of the cofactor matrix that we have. So to find the transpose, we know that transpose is basically the rows becoming the columns. So to find the inverse of a 3 by 3 matrix, the process is a bit long. So the first thing is to find the determinants. So the determinant is not 0, it means we can invert it. The determinant was 0, it means we can't invert it. In this example, the determinant was not 0, it means we can invert it. So we went to the next step, which was to find the adjoints. So to be able to find the adjoints, the first step was to compute the minus. So the minus is where we take each particular element and then you cancel the row is found in, the column is found in, and the resultant 2 by 2 matrix is what you are focusing on. So you do it for each particular point or each particular position or element in your 3 by 3 matrix. Then from the minus, we do the computation using the determinant method, which is what we are doing over here. And then you find the particular minus. So the minus is the values that we have at the end of this computation. Then the next was to find the cofactors. All you need to do with the cofactors is that from the values that you've gotten from the minus, you input it into the 3 by 3 matrix. And then you just take note of the signs. So the first row is positive, negative, positive. The second row is negative, positive, negative. And then the third row is positive, negative, positive. So that's basically what we are doing over here. And then finally, the last step in calculating the adjoint or the adjacent was to do the transpose. So we transpose the cofactor matrix that we had. So this particular matrix is what we are talking about. So the last method was to this matrix. We transposed it and then we had this. So you can see that the rows are becoming columns. So this comes over here. This has now come over here. And then finally, the last one, which is this, has now come over here. So what we have here, which is this full thing, is what we refer to as the adjoint or the adjacent. So this is the adjoint or the adjacent. Then what you do is to input them into the formula. So this is the formula that we use to find the inverse of a 3 by 3 matrix. This same formula is what we use to find the inverse of a 2 by 2 matrix. So all we do is that we input the values that we had. So the determinants that we had was -1. I hope you remember that. So it will be 1 divided by the determinant. So 1 over -1 automatically will give us -1. Multiplying by the adjacent. The adjacent, as we know, is this particular result. So this particular matrix is our adjacent. So we just put that there. And then what we are going to be doing now is a scalar multiplication, because this is -1 and then we multiply it through with the adjectives that we have. So -1 times 0, -1 times 0, -1 times -1. So for each particular element, so 1 times 2, you write it down. -1 times -1 is over here. -1 times -3. -1 times -3 again. -1 times 1. And then -1 times 5. And you just compute it. So 0 times -1 automatically gives us a 0. Another 0 times -1 gives us 0. -1 times -1 is 1. 2 times -1 is -2. -1 times -1. So negative, negative, we get a positive. Then -3 times -1, we get +3. -3 again times -1 will also give us a positive of 3. That's what we see here. And then 1 times -1 will give us -1. And then 5 times -1 gives us 5. So this value that we had, this is what we refer to as A inverse. So this is the step-by-step process that we follow if you are asked to find the inverse of the 3 by 3 matrix. So you find the determinants, and then we need to find the adjoints. We need to find the adjoints first. You need to find the minus. Then from the minus, you calculate the cofactor matrix. When we are done finding the cofactor matrix, we transpose it. The result of the transpose is adjoint matrix. So what we do is just dividing the determinants that we had, and then we use that as a scalar value to multiply through the adjoints that we had. Do we have any questions? Any questions so far? Any questions so far? Are we all okay, or do we have any questions? Any questions? Any questions? Okay, so this is basically what we go through. So we've looked at the determinant of a 2 by 2 matrix, determinant of a 3 by 3 matrix. How do we find the inverse of a 2 by 2 matrix? How do we find the inverse of a 3 by 3 matrix? So that is basically the process that we go through. So we've seen that. So the very last thing, I'll quickly go through the very last thing, which is how do we solve simultaneous equations if we are using matrices. So we all know what simultaneous equations are. So a simultaneous equation is basically two equations. So we have, as we can see over here. So we had this equation. So this is equation 1. And then this is equation 2. So the first equation will be a1x plus b1y will give you a c1. a2x plus b2y will give you a c2. That's the second equation. So to be able to calculate the determinant, so this is building on what we have done. So we looked at determinants, and then we looked at inverse, and we saw that the inverse was building on the determinants. In solving simultaneous equation, you will use the knowledge from the determinant and then the inverse. So when you determine when you get to know which is your first equation and then which is your second equation, then you basically represent them using this particular way. So the first part was A1x plus B1y. So A1 and B1 become the first row of the 2 by 2 matrix. A2 and then B2 become the second row multiplied by your x and then your y, which gives you a value C1, C2. So this is the matrix representation, this particular thing. This is the matrix representation of this. So if you have two simultaneous equations and you wanted to multiply them or look at them using matrices, this is how you do your representation. Then in solving, the next will be to determine the inverse of the 2 by 2 matrix. So inverse of 2 by 2 matrix is very simple. All you do is that you find the determinant. So this formula is more straightforward than the step-by-step that we've been doing. So this formula will basically give you your determinant of a 2 by 2 matrix at a go, because the inverse. So the inverse of the 2 by 2 matrix is 1 divided by the determinant. The determinant is A1 times B1. That has been written over here. And then B1 times A2, that has been written over here, multiplied by the adjoint. So the adjoint, just swap the main diagonals, and then for the off diagonals, you negate it. So from this, we get our inverse. Then from the inverse, what you do next is each side of your matrix. So this side, so this side is the first side, and then this side is the second side. So you multiply each side by the results that you had from here. So the results that you have from here, use it to multiply each side, and then from there you calculate your corresponding element, which is your x and then y. So we'll quickly go through this example. So we had a 2 by 2 matrix. We had two simultaneous equations here. So simultaneous equation 1, and then the equation 2. So we have to represent it using matrix, right? You know, the representation will be like this: 3, and then 5, and then 4, and 3, like this, which is multiplied by x, and then y would give us 7, and then 90. So this is basically what we'll be looking at. Then we are supposed to find the determinant of this, right? And then when we calculate the determinant, we use that to find the inverse. So if we are calculating the inverse, so let's assume that was A inverse. So our A inverse would have been equal to 1 divided by the determinant. The determinant would have been 3 times 3. 3 times 3 is 6, minus 5 times 4, which is going to be 'Then you multiply it with the adjoint. So it will still be 3, 3, and then minus 5, minus 4. And then from there, this 3 is negative. So this will become negative 3. So 3 would have given us minus 9 rather. So like this, it will be minus 9 like that, and then you end up getting minus 1 over 29, which is multiplying through minus 3, minus 5, minus 4, and then 3. So that's basically what is being done over here. Then you simplify it. So this was what you simplify to get this. Then when you are done, what we said was that you take this particular result that you had, this result, and then you multiply it over here and then over here. To multiply it on each side. And then we know that if you take a matrix A and you find the inverse of that matrix, if you multiply it, you get an identity matrix. So that's why this part you can already see the identity matrix written there. So when we took this and then we multiplied it with this, we get it an identity matrix. Then we take this and then we multiply it with this part. This is what we have over here. Then you do your multiplication. So you work through with the multiplication and then you break it down. And then finally, what you get is what would be referred to as your X and then your Y. So that's this part. If you do the multiplication of the identity here, it will basically lead you to this. And then when you do the multiplication over here, you will basically end up with this particular 2 by 1 matrix. So which is this. The corresponding values to the S corresponds to the top part and the Y corresponds to the bottom part. So you can see that X is equal to 4, Y is equal to minus 1. Then to find out if your answer is correct, you can just input the result back into the original equation that we had. So the original equation was this. This equation is what I'm talking about. So input the results for X here and the results for Y here, and then you compute it to see if you get the 0. So if you actually get the 0, then it means that your result is correct. So this is how you do it for the 2 by 2 matrix. There's the way to do it for the 3 by 3 matrix too. So it's the same thing. You go through it, then you compute the adjoints. Then when you are done with the adjoints, you multiply it on each side. When you are done multiplying it on each side that as has been done, then you find the final result of your X, Y, and then you see, and then it corresponds to 2. Try and see if it's correct. You just input the values back, and then if you get 0, 0, 0, it means that your result was correct. So these are some questions that we can try our hands on. So that's basically it. So we've seen the determinants, we've seen the inverse, and then we've seen how we solve simultaneous equation for the 2 by 2 matrix, and then how we also solve it for a 3 by 3 matrix. Okay, so the last part is quickly just going through the assignment. So this is the assignment that we had. So we are given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're given 10 matrices. So we had 10 matrices, and then we're supposed to compute, perform some operations on them. So we have additions, we have some subtractions going on, we have some scalar multiplications going on. So if the first question is A and B, if A and B can be added, you just work through it, you see your results, you do the same for all of that. So this one is scalar multiplication, and then you add scalar multiplication, there's some addition and subtraction. This one is matrix multiplication. So we have A and then the H. Can we multiply A and H? If yes, then you go through. If no, you explain why. So you do that for each particular question that we have there. Then the second part was in finding the value. So I said if you have a question that says calculate the value of the matrix, determine the value of this matrix, calculate the determinant. It's all the same thing. You are just basically being asked to calculate the determinants. So for this matrix, the 6 matrices that we have here, what you are supposed to be doing is just calculating the determinant. So you calculate for the 2 by 2 matrices A, B, and C, and then when you are done, you calculate the determinant for the 3 by 3 matrices D, E, and then F. Then you just submit your solutions. So that's basically what we are supposed to be doing regarding the assignments. I said I've received 5 submissions so far. So I've received one from Ibrahim, one from Johnson, one from Emmanuel. Then there's Paul. Oh wait, there's another Emmanuel. So there's Emmanuel Mensah and there's Emmanuel Aniba. So I've received from 2 Emmanuels, 1 Paul, 1 Johnson, and then Ibrahim. So 5 students I've received from these 5 students. If you are yet to submit your solutions, you can just work through it, whether you want to type it or you want to write it down. However you want to do it, just get it done. And then you send me your solution in a Word document or via PDF. So that's basically it for today's class. Do we have any questions? Someone was asking a question earlier. I don't know if you still have that question. Do we have any questions? You can unmute and speak, or you can just type it out.
Hello, madam.
Okay. Yes.
Please, sorry. I wanted to ask calculate the question 2, the value of the following matrix. I didn't get the question, so I couldn't do it.
Which question, sir?
The question 2.
The assignment.
Yeah, the
Yes,
assignment.
what I'm saying. So the question 2, if you see calculate the value of the following matrices, is basically the same as calculate the determinants.
Okay.
So that's what this question is asking you to do. Just that I didn't use the word determinants. So you are just supposed to be finding the determinants of the matrices. So that's all you would have to do over here. If you're not able to do, you can do it now and then you send that as a response. So don't send a new one, just under what you said. I think I've responded to your submission. So you just send it over there that this is the solution for the question 2.
Okay.
So question 2, as I said, if you see calculate the value, determine the value, it's all the same thing as calculate the determinants. It's all same thing. So you just use the determinant process and you calculate. Does anyone else have any other questions?
Madam, please, I want to ask another question.
Yes.
So please, I can do the question 2 and resend it as an attached file to the.
Yeah, that's what I was saying.
Okay.
So
Okay.
just do it and then you send us a response. Don't send a new email.
Okay.
What you sent originally now, just respond to it
Alright.
so that I can easily see that this one is just a continuation.
All right. Thank you.
If there's any, you're welcome. If there's anyone else that missed that part, you can just do it and then you just send it as a response to what you have sent already. Do we have any other question? Any other question, or we are all okay? Are we all okay? The what? You were saying the okay. Okay, so this is this is the provisional. I don't know if this, I'm sure it should have been shared on your platforms too. So this is the provisional mid-prime schedule. So the schedule, the mid-prime for Math 104 will be having it next week Saturday, or no, next 2 weeks Saturday rather. Yes. So math will be next 2 weeks Saturday. So you can see here 19th. So 19th is next 2 weeks Saturday. So that's when we'll be having the mid-prime. I'll make a recording, not a class session, because I'm sure most of you will be busy. I'll make a recording on differentiation, just the very, very basic aspects on differentiation that you can focus on for the mid-prime. So I'll do a video recording on that, the same way as we are doing here. So I'll record the lesson, very short, very, very simple on just the basic aspects to introduce differentiation to you. And you just go through that in addition to what we've done on the matrices and then the assignments that we've had and then the questions in the slides. So you see that when you're going through, there are some try your hands that are not assignments. So you just go through those two and then you just use that to prepare for the mid-prime. So the mid-prime is next 2 weeks. You can see the 19th. You just use that to prepare for the exams. Let me see. Are we supposed to have another assignment? Yes. So you are supposed to have another assignment. So the second assignment. So the second assignment is supposed to be published today. So I'll try and publish that maybe tomorrow, Sunday, or God willing on Monday, so that you get to have access to it. So the differentiation question, sorry, the differentiation recorded video, and then the video on, sorry, the assignments too would all be published hopefully next week, the early part of next week. And then you can just go through that in addition to what we've done on the matrices, and then you use that to prepare for the mid-prime. So this basically what you expect from the mid-prime. So questions on matrices, the additions, the subtractions, the scalar multiplications, the matrix multiplications, the determinants, the inverses, and then simultaneous equations, and then something more on the little that we cover on the differentiation. So that's basically what we have to note down. Please, I hope it's all okay with us. We are all okay, right?
Okay, please, in all, how many questions are you going to answer?
Pardon?
I mean, the main stem, like in all, how many questions are we answering?
It's just the usual format. The
Like me,
next one
I'm
you already format. It's just the usual format that you use for next one.
I'm a new student, so.
Oh, okay. You don't know the. Okay. Sorry.
Oh.
So let me show you the template so that you get to see how the questions are structured. So I have to share something else. Okay, so this is the template that we use in setting your mid-prime questions. So the end of prime also follows basically the same format. So what you see is at the beginning you get to see mid-prime, or this mid-summer exams, okay. 2024 next trimester, yes, the dates, the course code will be here, the title, lecturer's name, and then the duration would also come. Then this is what you take note of. So we have 3 parts, part A, part B, and then there's a part C. So part A has 5 questions. Those are general questions. Everybody has to answer it. So 5 questions, you answer all of them. Then part B has 3 questions. In those 3 questions, you answer any 2 of them. So there's part A, part B, and then part C. So you answer any one question. So you answer any one. This part you answer any 2, and then this part you answer all questions. So this is basically how the questions go like. So you get to see. So when we scroll down, the next that will come is exams paper tableau. This basically gives you the topics. So you see the topics that you've done. It will all be listed over here. Then the question number that those topics are on. Well, I'm not sharing anymore. So like this. So you see, so that's the first part. So the first part is just on the paper, what it's about. Then the next part is the topics and then the questions. So maybe question 5, question 6, then the topic will be there. Then this part is for you to indicate if it was taught in class or not. Then the main things that, so part A is understanding questions, 5 questions, compulsory for everyone. You answer all 5 questions. So question 1, 2, 3, 4, 5. So each question is graded out of 5. Then the total becomes 25. Then in part B, which is application and analysis, you have 3 questions. You attempt any 2. So you attempt any 2 of the questions. So you attempt 2 of them. So you have question 6, question 7, and question 8. And then each question carries 25. So question 6 has A, B, C, D. So A is 7, B is 7, C is 6, and then D is 5. Total gives you 25. Question 7 to has A, B, C, D. A to has A, B, C, D. Each part leaves you 25. Then question C is the evaluating and then the creation. This part, you have 2 questions and then you answer only one. So question 9 will have 4 sub-questions, A, B, C, D. Question 10 will have 4 sub-questions, A, B, C, D. The total for question 9 is 25. The total for question 10 is also 25. You answer any one that you want to answer, then you are basically done with the paper. So you answer part A compulsory 5 questions, 25. Then part B, you answer 2 questions, 25 each. Then part C, you answer 1 question, which gives you another 25. And then the total. I hope we are all okay. Is it okay with us? We are
Yes,
okay,
madam.
right?
Yes, please.
Okay. So this is basically that I said the question that you be yes, so the questions you are expecting is on matrices and then differentiation. The matrices will be the major focus, so like 85-90% will be on matrices, and then some few questions will be on differentiation. So matrices, everything: addition, subtraction, multiplication, determinants, inverse, simultaneous equations, and then some 1 or 2 questions on some basics of differentiation, and then that will be it. So you answer 5 for part A, everything. Then part B, you answer 2, part C, you answer 1. And then at the end, you get your 100%. So you try to do the assignments. I'll be posting the second assignment And then the questions too that you have in the lecture material, some questions that are not assignments, you try your hands on them just so that you are able to prepare for the exams. Okay, so that will be it for today's class. I think we've kept a long time here today. It's longer than the previous class. So thank you
Yeah.
for coming, and then thank you for staying through the long class. So yes, look and look forward to the material on the differentiation and then the second assignment. And if you have yet to submit the first assignment or you did part, you've not done everything, please just complete it and then send it to the email. So that would be it. Thank you all for coming, and then all the best to you. Enjoy your weekend too.
Yeah, we can too.